Hello, I'm Rodney Herring. I'm the Chief Technical Officer of a company called Earth Clean Crystals located in Victoria, British Columbia, Canada. Uh, the title of my talk today is for the ICMSN 2026, which is happening June 22 to 23. The title of my talk is Effectively and Efficiently Disinfecting and Cleaning Pollutants from Surfaces, Water, and Air using an iron-doped titanium dioxide crystals. These iron-doped titanium dioxide crystals are sometimes referred to as steri-clean crystals. Uh, in background, they're based on titanium dioxide, which is FDA approved for unlimited consumption in our food. My crystals can be made larger than 100 nanometers using a cyclone filter, so it addresses the nanotechnology issue that's a European concern. We have been using titanium dioxide as food thickener, cosmetic-based toothpaste for around 90 years with no measurable adverse health effects. A good example for food is the white shell on the Smarties chocolate candy. In addition, titanium dioxide makes the paint in our houses, so it's ubiquitous. The problem with pure titanium dioxide is that it requires ultraviolet light to generate hydroxyl radicals. It has a very high recombination of the charges should the crystals be activated, which creates a low catalytic efficiency. Ultraviolet light is expensive and carcinogenic. It doesn't pass through glass except expensive quartz, and it doesn't easily pass through water absorbed with few millimeters. It's absorbed within a few millimeters, so deep penetration isn't possible. Uh, the problems overcome by using clean crystals include degradation of many types of organics very efficiently, ammonia, forever chemicals, but not PFAS, metal organics, coliforms. I'll show some data with bacteria, viruses, and mold, as well as aerosols. I'll show how they're being used to remove smoke and gases from our air. And the nice thing about using them is that there's no biological response. Uh, there has been publications on these crystals. We going back to around 2018. I started this project about 10 years ago. We can see here there's a nice one, significant improvement in visible light photocatalytic activity of these types of crystals using an acid treatment process that was in Applied Science. There's another one, acid treated iron doped titanium is a high performance photocatalyst. And there's one that is showing the effect of germicide photocatalytic activity of these crystals. There's several patents involved with this. The foundation patent is #1 in the blue here. For cleaning surfaces, water, and air, these ones in the red are all concerned with that. And then there's several that are concerned with health applications. So there's quite a few. This shows some of the patent numbers and stuff like that if you need or want to go and investigate them. And so we can just if you're interested in contacting me after this and want to discuss something and specifically the patents, we can discuss these separately. So this is an example of the crystal produced iron doped titanium dioxide, and it can be activated using visible light or electricity to produce hydroxyl radicals. The size can be adjusted from tens of nanometers to 100 microns, so avoids that nanotechnology stigma. Perhaps this crystal here is the most efficient producer of hydroxyl radicals by any means. We have a electricity generated, a reactor generating these hydroxyl radicals, and you'll see that it's very, very efficient and low power. And why do we want hydroxyl radicals? Is because they have the highest oxidation potential. It's so strong that the lifetime of this radical is from nanoseconds to microseconds. So one may ask, how can you actually measure the production of hydroxyl radicals when it disappears so quickly? Well, here's a nice method. We tried many methods, but eventually I came up with this method where we put benzene into some water and we put the reactor generating hydroxyl radicals, and it produces phenol. Both benzene and phenol are very easy to measure using a UV spectrometer. Eventually, all the hydroxyl radicals will degrade this to carbon dioxide. So we can see here in this UV absorption spectrum that initially we have a concentration of benzene. Hydroxyl radicals are being generated, so its concentration is decreasing. We can see that it's producing phenol. So we start with zero amount of phenol, and then over time, the phenol increases. So this enables us to measure the efficiency of generating hydroxyl radicals. And we find that going through the reactor, 4 electrons will generate 1 hydroxyl radical. But if we do combine this with the PEM membrane of a fuel cell, we can increase this efficiency to 2 electrons passing through the reactor for 1 hydroxyl radical. So it's really quite amazing at how strong it is. We can put the crystals onto glass, and specifically, as we see in the left-hand side here, fiberglass, and you can see all the little crystals on it. Or we've learned how to stick them on to metal ceramic composites so that we can apply the crystals and not lose them to the environment. And the other nice feature about this is that they're self-cleaning. Here's an application of them with the air filters. And if we just go to Home Depot or a store, we can buy 3 HVAC filters for $13.98. These filters here, the cloth in there is actually fiberglass cloth. And so all we do is we use the standard filter here as a scaffold for our cloth. And we find that it's very effective. It's being used for a Cowich and Creamery, which is a cheese company, as well as a Vancouver office building. And the cloth itself with the crystals is very cheap. It only adds $1 to the cost of the filter. For cleaning water, we have another method of doing it, and this uses water. So we have a reactor which water is flowing through the fiberglass cloth with the crystals on it, and we have electric current passing through, which generates hydroxyl radicals. And then when the water passes through the pores of the fiberglass cloth, air passes through, and we find that it's able to remove things like bacteria, nanoparticles, aerosols, odors, and smoke. And we get those, and we can collect these contaminants in a reservoir below. And what's nice about this air filter, it's not pore size dependent like HEPA filters. It's an active three-dimensional air filter. And here is a small prototype of this. So the water comes in, it flows down through, we pass air through it, and we can see how well it does for cleaning the water. Here's a larger air filter for a office building, and for high rises, it's just larger, so it's very easy to scale. Right now, we're looking at making one in Middle East. It has a size of, they use feet there, 12 feet by 15 feet. So these reactors, air filters, can be made quite large. And essentially, if they're applied in an HVAC, we can see we place these filters at different places along the HVAC. There's moisture added to the air as it's passing through, and that moisture has the hydroxyl radicals, and so it's disinfecting as it comes along. At the end, you have an air filter that adjusts the air for the temperature, pressure, and humidity. This shows a good example. In the lab, we have the air blower over here, the air filter in here. Here's the heater. We have diagnostic chambers. So it comes in, and this is the air conditioner, which removes the excess moisture, and it brings it down to a reservoir which recycles the water back into the air filter. This shows this air filter removing dust from the air. And as you know, in cities these days, in many places, there's a lot of dust. It's coming from tire degradation. But also these days, we have a lot of smoke in the air. And so we tested it with smoke, and you can see that it removes smoke quite nicely. And we can measure the composition of these particles. Additionally, here's we have a smoke particle, and you can see that there's lots of nasty things in that smoke particle. So it's nice that they're being removed. Here's a smoke particle with a high sulfur content. So it's, as we know, there's a lot of sulfur, H2S in smoke. So it's being removed. And the reservoir, if we have lots of H2S, we can see that it's turning acidic. Applied for masks. The world now is getting more comfortable with wearing masks. They are pore size, just like the air filters, the HEPA filters. And unfortunately, the pore sizes are too large and they don't remove viruses. So it would be nice to have masks as antimicrobial. And this technology is able to do that, but we're even looking at making clear glass masks with the crystals on them. So it would be both clear and antimicrobial. And this shows the fiberglass cloth with the crystals on it. You can cut it out to face mask design. This shows an actual face mask that was tested. We refer to it as Katie's Fresh Breath because it removes odors as well. The cost of this added cloth here is about 1 cent. And so it's very, very cheap. We've had several independent verifications. This is with a government-approved lab in Edmonton, Alberta. It's Keystone Labs. We find that it removes the E. coli in staph. This is the visible light activation of the crystals, and it reduced it by 1 to 3 logs. So you can see reduction of 99.8% and 93% for the staph. This is there's hospitals in Southeast Asia using it for cleaning their wastewater. And we see in this official government test here, they start with 3 liters of water where there's 49,000 coliforms per 100 milliliters. After running our reactor in it for 1 minute, the coliforms are reduced to less than 1.8 per 100 milliliters. So it's very, very effective, 4 log reduction in 1 minute. And we've also tested it with the COVID virus. This was at the Center of Microbial Chemical Biology at McMaster University in Hamilton in Canada, using the ISO 21702 guidelines. And we can see that 99.9% of the viruses are removed. We've had also independent toxicity tests specifically for our crystals, and we find there's no toxicity. So if we look here, any kind of R value of around 1 shows that there's no toxicity. This is our crystals, and there's dilutions here. So this was also conducted at the Center of Microbial Chemical Biology using these guidelines. So that's my presentation. As a local BC, British Columbia, Canadian company, the goal is to help keep our earth, people, and environment healthy and clean. We look to have collaboration. Win-win is a must. And if you're willing to partner with us in promoting this, you can contact me at my email address, rherring@uvic.ca. So this is my talk. And in conclusion, use SteriClean crystals for what they're worth. Thank you.